Hi everyone, this is Mrs. John again with another question about two-point source interference. This time it is question 4 and this is for year 12 physics. So in the diagram, S1 and S2, these two, are two-point sources creating waves of wavelength 1 centimeter. So what's actually happening is these are creating waves and so is this. Circular waves. So they haven't drawn the circular waves, but that's what's happening. And the wavelength is 1 centimeter. Now point A is 5 centimeters from S1 and 6 centimeters from S2. And they give you details about B and C. We'll come to that soon. But the question says, explain whether A, B, and C are nodal or antinodal points. So before we can explain what they are, I just want to go through what's the meaning of antinodal and nodal points. So antinodal points are areas of constructive interference. This is where the waves arrive in phase, which means a crest combines with a crest and a trough combines with a trough. So these are high energy areas, high amplitude waves. The important thing, the path difference is 0 wavelengths, 1 wavelength, 2 wavelengths. It's a whole multiple of wavelengths. So path difference is the difference in distance traveled by the waves from each of the two sources. Okay, and nodal points, on the other hand, are areas of destructive interference where a crest combines with a with a trough because the waves arrive out of phase. The effect is to cancel each other, and these are low energy areas or areas of calm, and the path difference is half a wavelength or odd multiples of half wavelength. So this question is essentially to work out path differences and say whether it is nodal or antinodal. So path difference for A, so I'll write that there. Path difference is 6 centimeters minus 5 centimeters, which is 1 centimeter, which is 1 wavelength. So that is an antinodal point. Okay, I use a different color for B. Now let's see what's happening at B. So B is 4 centimeters from S1 and 2.5 centimeters from S2. So from S2 to B is 2.5 centimeters, and from S1 to B it's 4 centimeters. So for B, the path difference is 4 centimeters minus 2.5 centimeters, which is 1.5 centimeters. So that's 1.5 wavelengths. So that is a nodal point because it's an odd multiple of half wavelengths. 1.5 is 3 half wavelengths, right? Okay, now let's come to C. So I'll just use a different color for C. Let's use green. Okay, point C, that's where C is, 8.5 centimeters from S1. Oops, sorry, my line's gone wonky. Okay, so let's do that. So this is 8.5 centimeters from S1 and 7.5 centimeters from S2. So for C, your path difference is 8.5 minus 7.5, which is 1 centimeter, which is equal to 1 wavelength. So that is an antinodal point. And that's how you answer this question. Bye for now.